In this video, we're going to learn how to make this bumper robot, which when it's finished, will work as shown in the video. There are two bumpers, one on the front and one on the back, and whenever the robot hits one of the bumpers, it will go in the opposite direction to that bumper. So when it hits the front bumper, it will go backwards. When the bumper on the back is hit, it will go forwards. And there's also a slight turn programmed in as well, so each time it hits a bumper, it will make a slight turn so it doesn't just end up going back into the same place it was originally. Each of the bumpers is effectively a switch, and this enables the JackBord to know which one of the bumpers has been bumped. The program inside the JackBord is what determines the action the robot will take, for example, what it should do when the front bumper is pressed, and what it should do when the rear bumper is pressed. Looking at the circuit diagram of the bumper robot, basically you have two switches, the front bumper switch and the back bumper switch. The idea being that when the robot bumps into something on the front, the pin on port A1 will be pulled low, and that tells the JackBord that the front bumper has been triggered. Likewise, if the robot bumps into something in the rear, the switch on port A2 will be triggered, telling the JackBord that the robot has collided with something behind it. Looking at the diagram, you can see that the relationship between the front bumper and port A1 and the back bumper on port A2. Both switches require a common ground, and you can see this is the one wire that goes to the ground pin on port A. This picture shows the two switches on the right-hand side of the robot. The top switch, which is the top round circle, is the switch for the front bumper, and the lower round circle is the switch for the rear bumper. The switch is just like any normal switch. It has two contacts. One of the contacts is the wire itself with the circle, and the second contact is the bolt that comes up through the middle of it. When the robot runs into an object on the front, the wire is pushed against the bolt in the middle, and that closes the switch. This is just as if you had a push-button switch and you pushed the button. This then tells the JackBord that it has run into an object at the front. The same principle applies to the switch on the back bumper. As you can see from the picture, another JackBord has run into our robot and closed the switch. This tells our robot that something has hit it from behind and it needs to do something about it. This again is just as if a push-button switch had been pressed. In the case of our robot, when the front bumper is hit, it will go backwards and make a slight turn. When the rear bumper is hit, it will go forwards and make a slight turn. Next, we're going to learn how to build the robot. To build the robot, you're going to need the following items: some 20mm M4 bolts, some M4 normal nuts, and two M4 nylon nuts. These are the ones that will lock. M4 washers, some 10mm M4 bolts, two lengths of 1.25mm wire, about 36 centimeters long each, some milk bottle tops, or just some pieces of plastic cut out of the side of a drinks bottle. A piece of wood or plastic that you can use as an insulator to mount the wires. This needs to be about 5 centimeters long by about 20 to 30 centimeters wide. And 3 crocodile clips with DuPont connectors on the end, which you'll use to connect the switches to the JackBord's port A. The first thing we need to do is take the piece of wood, it should be about 5 centimeters by 2 or 3 centimeters, and mark the two mounting holes that will be used to connect it to the JackBord itself. These need to be 15 millimeters apart, and you can use a piece of Jackano as a measurement. So for example, we've used a 3-hole angle bracket here to make the measurement for the holes that we need to drill. Next, mark out the 4 holes that will hold the wires that will make up the bumpers. The 2 holes on the upper left will hold the back bumper, and the 2 holes on the upper right will hold the front bumper. All of the holes in this project are M4 or 4 millimeters in diameter. Once the holes have been marked, use a drill with an M4 bit in it to drill out all of the holes. Your wood or plastic should now look like this. So we need to make the two bumper wires and then bolt them onto the insulator as shown in the picture. To start with, take one of the pieces of wire and bend it around one of the M4 bolts as shown in the picture. This will give you a loop through which an M4 bolt will fit. Take the piece of wire with the loop in the end and thread it through one of the holes on the outside of the insulator as shown in the picture. Once you've done that, take one of the 10mm bolts and push it through the hole so that it goes through the wire loop as well. After that, attach a washer and one of the M4 nuts. When you're done, it should look like this. The one you're seeing here is the front bumper wire. Repeat the process for the rear bumper wire. Once you're done, your assembly should look like this. The wire on the left of the photograph is the front bumper wire, and the one on the right side of the photograph is the rear bumper wire. Now we need to make the loops in the end of each of the bumpers. To do this, find something like a whiteboard marker that is about 15 or 20mm in diameter. Take the end of each bumper and wrap it around once so that you end up with a circle. When you've made both circles, they should look like these. Take the two 20mm M4 bolts and insert them on the right-hand side of the JackBord as shown in the picture. These will make up the other half of both switches. Now we need to attach the bumpers to the JackBord like this, using two 10mm M4 bolts and two washers as well. Notice that the nuts are on top of the JackBord. This makes it easier to tighten them. Once the two bumpers are bolted on, your robot should look like this. Notice on the right-hand side that the two loops are not mounted over the bolt. You need to adjust the tension on each of the wires so that the center of the circle is occupied by the two M4 bolts that we put in earlier. These will be the opposite contacts for the switches. Once the circles are centered over the bolts, your robot should look like this. Our next job is to make the plastic insulators that will go on the top and the bottom of each of the circles. In our example robot, for the bottom insulator, we've used a blue milk bottle top, and for the upper insulator, we've used some plastic that was cut from the side of a plastic bottle. The top of an ice cream container lid is just as good and easier to cut out. We used a clear top insulator in this video so you can see the operation of the switch later on. Mark the centered holes as shown. Then use an M4 or 4mm drill bit to drill out the holes, and your insulators should look like these. Take your first two insulators and mount them onto the two M4 bolts as shown in the photograph. Now take the other two insulators and put them over the bolt so that they cover up the two loops. Your robot should look like the one shown in the picture. To stop the insulators coming off, use the two M4 nylon nuts on the two 20mm bolts and just hand tighten them. The nylon in the nuts stops them from coming off accidentally. Looking from the side, you can see that the metal ring is between the two insulators. The reason we do this is that as the robot is driving around, it stops you getting false triggers on the switches due to the wire bouncing around. So the two insulators serve as dampers. If all has gone well, your robot should look something like this. Take some time to compare your robot with the robot shown in the picture and make sure that everything is the same. Now that we've got the mechanical side taken care of and our two bumper wires are mounted, we need to connect them to port A of the JackBord. The picture shows how the connection should look once they're done. The first connection we need to make is the ground wire, which in this case is a green wire with an alligator clip on it. This connects from the ground pin on port A to some metal part of the JackBord, in this case the outer edge. Now that we have the ground connected, the next wire to connect is pin A1 to the front bumper. We do this by connecting another alligator clip to pin A1 and then clipping it onto the front bumper as shown in the picture. Make sure that the alligator clip has good firm contact with the bumper and that it's on the inside and not the outside. And finally, we need to connect the rear bumper switch to port A2 on the JackBord. In this case, we've used the blue crocodile clip wire. Clip the other end securely onto the rear bumper where it attaches to the insulator. Again, making sure that it's on the inside of the wire, not on the outside. If it was on the outside, it might get bumped off when the robot hits something. Now that all the connections have been made, compare what you've done with this photograph and make sure that each of the connections that you've made match the ones in the picture. Here are some more views of the completed robot. Compare what you've done with these different views, taking particular care to check your wiring and all of the connections to make sure that they match. Once you've done that, in the next video, we'll look at the software needed to control the robot.